Hey everyone, this is Andrea back with another research conversation, and I'm trying to write some papers and connect some dots as I build this general navigational framework for cognition, trying to sort of clarify the similar movement that I see across various fields and disciplines that's sort of reorienting us ecologically, so we can understand cognition and consciousness, which are not the same thing, by the way, but more on that in a solitary research post. In any case, I've been thinking about all this as I work on some papers, and so I revisited a conversation I had with Michael Levin, and I want to post it today. And it's been a very important conversation. This is just part one. I'll post the other parts later, but this dialogue that opened between he and I is very important for me because I only just discovered his work, at least the work relative to navigation, a couple months ago in the summer when we were both part of this Society for Multidisciplinary and Fundamental Research. It's SEMF, S-E-M-F, Society for Multidisciplinary and Fundamental Research. We had, we both were talking there, and one of the papers that he was talking about then was analyzing cognition in diverse embodiments, competency in navigating arbitrary spaces as an invariant for analyzing cognition in diverse embodiments. And that paper is saying something very similar to what I've been sort of saying in a more generalized way, and what I've been using hippocampal research to delineate philosophically, which is, in short, that the best way to understand cognition is as waymaking, or as navigation. Although I don't use the word navigation, because it has a really specific meaning, which means goal-oriented, which is actually how Michael uses it and is an important part of his work. So we discuss this a lot. I think it's more in part 2 than in this section, but all this just to say there's a lot of really interesting themes that overlap, but not fully. They're not parallel between his work and my work. Of course, I should say he's a very successful scientist working as a developmental biologist with a lab. And what I'm trying to do is come up with a philosophical framework that would sort of unite his work with other scientific work that I see happening in other different fields. I'm more or less trying to come up with sort of the background framework of how we can really think of cognition. So finding his work has been incredibly important for me for that reason. I'm still trying to understand it all. That's why I'm having all these conversations with him. And this is the first one where we meet each other. So I want to go ahead and post it and just leave it sort of as it is. I imagine you already know Michael Levin, but if you don't, he's a biologist at Tufts University, and he's making new paths towards understanding complex pattern formation in biological systems. I had seen a talk he gave a couple years ago when I was studying neuroscience, not a couple years ago, like in 2017, and about planarians, which just totally, it rocks your world if you've never come across this biology that he's doing and you see him talk about it. He wasn't talking about cognition as navigation then, but that paper came out just very recently, I think. I'll put it all in the show notes. In any case, his work is amazing, not just for what I'm talking with him about, for many things. So really check him out and look at what he's doing. It's pretty mind-blowing. He's also developed something more recently called TAME, the technological approach to mind everywhere. I won't even try to summarize it, but I'll put it in the show notes. But again, it has a lot of overlaps and a lot of stuff that I want to really think about, like how we use these terms mechanical and life. I see them as different, but I think Michael would sometimes just say like machines, he would say, these different life forms are machines. And in a way we are saying the same thing, but we're using different language with really different trajectories coming from different places. And part of all these conversations is trying to figure all this out and get some clarity on it, because a lot of times in our disciplines we talk about the same things, but we use different language trajectories, if you know what I mean. Like we're using different references and sometimes different words to mean different things, and we don't realize it. And this obviously can get really messy, so that's part of what I'm trying to figure out here too, because it is a form of waymaking and it relates very much to this overall framework that I'm building for cognition. So all that just to say, Michael Levin is doing some amazing work. I was lucky enough to get to talk to him and to be in a conversation with him, and I'm just going to keep posting those here in different parts. So that's what this is. I'm not even going to edit it much or anything. I'm trying to see how it overlaps with a lot of the phenomenological and network models that I've been working with. Everything from like Varela and Maturana to Hans Jonas and Nadal and O'Keefe and the hippocampal stuff, active inference. There's a through line through all of this, and I'm trying to sort of bring that out And Levin's work is really important as a part of that. Not only an example, but something that's, I think, shifting this paradigm of how we see cognition in very real scientific ways. There's something he says in here, for example, he's talking about intelligent. And he says that, I think he's telling me a story, and he says, when you say the word intelligence, people think human intelligence. And he says, well, that just has to stop. So he's just sort of bypassing a lot of the dichotomies that people accept. And people love his work. But of course, also they have a lot of trouble with his work at times because exactly for this reason that he's using words in ways they're not used to, especially when it comes to technology and machines and how it relates to life and intelligence, for example. So some people don't want to think plants and animals have intelligence, not to mention something like AI. Another interesting part of this conversation I found was him talking about how science fiction as a kid reading opened him up to thinking beyond dichotomies in a way, that he was already able to see something like a machine and something like an insect and an animal as somehow related, not the same thing, but somehow related and continuous, because the technologies we build don't come out of nowhere. I mean, they are connected to us. There is a continuum. It's just we have to figure out what that continuum is and how we can best understand it and direct it. In any case, I liked hearing that it was novels and science fiction that opened his mind, and he never even thought there was a difference, as you'll hear him say, between the TV and the caterpillar or whatever. He just was trying to understand it all as one process. So anyway, thanks for being here, and I hope you're doing well out there wherever you are. And write to me anytime if you have some ideas about how all this fits together. Okay, see you.
Sure. Great.
Awesome. Got it. Thank you very much.
Yeah, no, it's a pleasure to meet you.
Yeah, it's a pleasure to meet you too. And I'm really excited about your work, and
thank you.
Thank you for your work.
Likewise. Yeah.
Yeah. So I wonder if it's okay with you if we could talk a little bit about how you got into this line of work and maybe how you ended up thinking about these kind of bigger themes like cognition and so forth.
Sure. Well, let's see. So from the time I was very, very young, I was interested in minds and how they interact in the physical world. Yeah. So, technology, but then bugs and insects, you sort of see and you ask yourself, so what's common? What's different? We know how the technology got here, sort of. How did the complexity of the living forms get here, and specifically the fact that they clearly have preferences. So some of them have overt behavioral goals and various repertoires, but they clearly have preferences about what happens. And then that raises the obvious question of, well, what would it take to create technology that had that, right? And is the kind of third person observable behavior all there is, or is there something else, right? So this is a kind of first person problem.
Were you looking at actually like insects and animals and stuff when you were a kid? Were you wondering like what do they what's going on there?
Yeah, I mean, it started out I had asthma and was kind of didn't have access to medications at the time, and so what my dad used to do is take the back off of this TV set with these vacuum tubes and everything, and I would sit there and just sort of get distracted and stare at it and be like, wow, like somebody knew how to put all those things in exactly the right arrangement. That didn't cool. Just like somebody knew how to do that. And then so, then I would go outside and play with caterpillars and beetles and so on, and you say, okay, so they also have a bunch of stuff in there. And so now what's the same and what's different, right, between these two?
You actually remember kind of making that connection?
Oh, totally.
We'll talk about it later maybe, but the way you use robotic and biological robotics and biorobotics, it's different, I think. And it's also kind of meshing those things together. So it's interesting you already saw it almost like a continuum as a kid.
Yeah, it seemed, I mean, it never occurred to me that there would be any kind of a discrete break between those two things. It just seemed like there are various kinds of behavioral repertoire, some very simple, some more complex. And then, the plasticity of it, I remember thinking like, so you see there's an egg and the egg becomes a caterpillar, and then yet it changes again and becomes a butterfly. And so you ask yourself, what's that like? What's that like to be to be a caterpillar changing into a butterfly in real time, not on the evolutionary time scale or whatever, but like literally one creature radically changing and living in a different world, in a three-dimensional world instead of the two-dimensional world of the caterpillar, and so on. And thinking about that, and then thinking about myself and watching my older friends, and they would, they get older, they go through puberty, whatever, and thinking, wow, like we change too.
Yeah.
And right, and not only do you get bigger, but your valence changes. So things that you really didn't think were at all important when you're 11, suddenly new things are important when you're 15, and so on, right, and whatever. So just thinking about that, thinking about persistence of the self and how your mind changes and whatever, and so those kinds of things. And so later, what I did was I went when I went to undergrad, I went for computer science. I wanted to do artificial intelligence, and pretty soon it became clear that we really didn't know how to do that, right? We just didn't have any idea. And then really going back and asking, okay, so let's take the N of one example that we do have from the biological world, and figure out what's going on there. And I was really sort of enamored with embryogenesis, and so this idea that it's a self-assembling machine, but more than that, it's like this. We all take that journey from nowadays. When I talk to people, somebody will say that's not cognition or whatever. That's just physics. Like, well, you were an unfertilized oocyte at one point. Like, you were a quiescent little blob of chemicals. You, like all of us, were just, I hate that phrase, just physics, right? And then somehow, slowly but surely, here we are. And there was no magic lightning bolt during development that says, boom, at this point you go from being physics and chemistry to being a being. That there's no sharp line there. And so I was really interested in that. And so I studied developmental biology as well as an undergrad, and then went and got a PhD in developmental genetics. And so that's where these things come together. Like, I'm just really interested in diverse embodiments of mind. I want to understand what it means to be an agent in a physical universe, and a lot of the kind of standard barriers that exist between fields, between journals, between ways that we're allowed to think about things, some of the terminology. Like, I think a lot of that is just terrible, and it holds back progress because it obscures important invariances that we can use to merge fields and to do better than we have. So that's kind of my story.
So yeah, I totally agree. And when I said coming upon your work was exactly what I was looking for, it's in so many ways because you don't really take the dichotomies seriously. You're just already kind of speaking past them, which I find very unusual. So what was the continuity that you saw? Like, if you're staring at the back of the TV set and you're looking at all of that, and you're looking at the caterpillar, the butterfly, your friends, and then, yeah, you obviously got very interested in artificial intelligence, but I guess some people would say that's really different, right? That the television set isn't necessarily evolving and changing, whereas what you described, like with the caterpillar or your friends, there's some kind of clear change going on. So can you tell me how did you see that? Did you see that more as part of the same kind of system?
So yeah, I mean, it was very clear that the TV needed a lot of help to be put together, right? It needed other beings to put it together. The caterpillar needs a little bit of help because there's the butterfly that laid the egg. And it was obvious that in the egg, there was some stuff that had to be also put in, right? It wasn't just a random, not just anything turns into a caterpillar. So clearly the butterfly had to do a lot of work too. Now, of course, there are differences. The engineers have a pretty good idea of how they're doing the TV set. The butterfly probably not. However, in both cases, there are two components to this. There's the how much help did you get from outside to be created? There's that component, and then there's the component of once you were created, how much do you do on your own? Because that's the other thing, right? The people who and so first with the TV, and TV's kind of boring, but with computers later on, you see that there's all sorts of interesting, after you turn on the juice, right? The job of the hardware engineer is done. You turn on the juice. Now some interesting stuff happens. And I remember playing with an early it's just a calculator, but you could already see that, yeah, they created the hardware, but there's also some really cool software that happens. And part of that is not explained specifically by what the engineer did. It's explained by the laws of mathematics and the laws of physics and then biology. And so of course there are different degrees of agency here, but it didn't seem to me like there had to be any strict barrier between them. It didn't, it didn't seem, and part of this is just thinking about it. Part of it was a lot of sci-fi that I read as a kid. When you look at these creatures, living creatures, I don't see, my intuition isn't that this is the only way to do mind. This is one way, but why would you think this is the only way? And people nowadays often say, well, it doesn't have a brain, and it, it's not living, or whatever. And I'm just thinking, it can't be that throughout the whole enormous universe, this thing with this cortex that we're looking at, that's the only way to do proper agency. I mean, it just can't be that. I just don't see that. So to me, it seemed like we have an N of one example of how it can be done, and then thinking about evolution and thinking, why should evolution have some kind of monopoly on creating real agents? Like, that's one way it happens, but surely engineers can eventually do better than this sort of random walk that evolution does. And why would it be the only way that real beings come? So I don't, this whole business of, oh, it's a machine, and what can machines do? I mean, I think it's a terrible question. It completely obscures the whole.
But it's almost an assumption, not even a question anymore. And a lot of the way just that we talk, that the literature is written, that there's these kind of scaffoldings that people don't think about very much, which you seem to have, and now I understand, and you're already sort of thinking past it, but trying to get a way for people to understand that. Does it have something to do with like what I call the agent base, or I think you use this agental a lot too? Like from your position, of course, the TV is going to look less animated or whatever in that particular position. We could also scale up or down, right? Cellular, or, even like in the TV itself, there's going to be sort of more action at different scales, right? Not maybe like your observer base. So yeah, I wonder, I know that plays a role in your work that I'm still trying to understand. So I don't know, what does that make you think of when I say that?
Yeah, so very much observer, thinking about what an observer sees at any particular scale, and the idea that what we do see is hugely limited by our own scale and what we are trained either by evolution or by experience to to perceive. And so this is something else that I think you really get if you read a lot of sci-fi, is they sort of blow up all those expectations, where something that is enormous in scale or very tiny or happens on a very rapid time scale or a very slow time scale, you sort of realize that our perceptual and cognitive systems are so narrowly constrained to think about and to be good at recognizing agency in a particular guise. So medium-sized objects moving at medium speeds through three-dimensional space. This is what we have any prayer of intuitively catching as intelligence. Anything that's outside of that, something that happens on a huge scale, like whole evolutionary lineages, or at one point I was talking to some physicists to see if we can design a gravitational synapse, like literally a solar system scale thing that when something comes flying through, that's a signal, and then the next time it comes, there's habituation or whatever, like you can imagine. So these kind of these kind of giant things where the substrate doesn't matter. It's and having to be open to really unconventional, and I should be really clear, this isn't just me having all these ideas. There are plenty of people in the diverse intelligence community that see things this way, but it's still obviously not mainstream in any way. But so this idea that the substrate isn't the magic. What is the magic? That's a good question, and that's what we're trying to understand is the scaling of mind and goals and all that. Yeah, and just this idea that I mean, there's also a fundamental thing here, which is I have a very kind of engineering approach to things in the following way. I think that the way to know if these things, if these ideas are worthwhile or not, is to see what they enable you to do, what kind of research programs they open up. And this, on the one hand, that makes it nice and easy, because now we don't have to have philosophical arguments about whether this can or can't be an agent or whatever. We can lay down specific research programs of how to determine whether that's a useful worldview or not. The downside of it is that it catches me a lot of flack from the organicists, because they see this as basically capitulating to kind of the mechanist worldview, and as a lot of people write to me, reducing the magic and sort of majesty of life. And I don't see it that way at all. My point isn't that we can or should try to reduce high agency kinds of systems to simple machines, the kind of thing, but people say machines, they really mean machines from up until the 1940s or so.
Yeah.
Right. So I don't think it's that at all. I think it's understanding the full spectrum and having a prayer of actually making progress, which means tight integration with engineering, with the real world. I don't think a lot of these things are philosophical questions. I think they're practical questions. And also it's this idea that it's been the assumption for a really long time in science that it's really bad to make a mistake to attribute too much agency, right? That it's a slippery slope. You start seeing ghosts and all the rocks and things, and you really should aim downwards, and chemistry is kind of the level at which. And so to me, getting it wrong in either direction is terrible. Like the slope is actually much slipperier. To me, the slope is much slipperier in the other direction, because once you start seeing once you start seeing everything as a machine, as a simple machine, it's really easy to have all kinds of lapses that first impair your technology, and then they have ethical implications. And so either direction I think is bad, and I think our job as scientists is to get it right for any given system. You don't just want the lowest level of agency you can get away with. You want the optimal level of agency that you need to attribute. And I think we often just assume that you got to go down as far as possible. And I don't. I think that screws us up as often as it helps.
Yeah, gosh, there's so much in there. It's you mentioned science fiction, for example, and just thinking about the scales and stuff. I think one thing about creativity, or about reading when we're kids, and is that we kind of learn how to see the world from different positions in a way, and in a way that's kind of helping us maybe to get a grasp on this perspective that I think you're talking about in your work, and that you do demonstrate practically, but that you say the philosophy doesn't matter, but
well, I didn't say it doesn't matter. No, so sorry.
Yeah.
So I didn't mean to. Maybe I didn't express myself well. I don't mean to say.
I don't know if you said it doesn't matter, but
I actually think it matters a lot, because people will say, I've had this after a talk. People will say, well, the data are really cool and the new capabilities really cool, but I wish you'd stop talking about all this philosophical stuff. Like, don't do that. Just do the science. And I think that's a huge error, right? It's like the old joke where the way the business guy tells the book publisher, just only publish the bestsellers. Why do you publish all this other junk? Just publish the bestseller. It's the same thing. And I say, yeah, if we didn't have the philosophical outlook, we wouldn't have done these experiments that nobody else had done before, right? That you need that. And so I'm not saying the philosophy isn't important. I think it's critical. I'm just saying that a lot of the questions that are often treated as philosophical questions, meaning that you can have an opinion on it without doing anything. So people sitting in their armchair, I'll show you some kind of a thing, and they'll say, there's no way that thing has cognition. I said, well, what experiments did you do to arrive at this opinion? They're like, you just sort of came up with that. That's a background, a commitment that you have before you've done any work at it. And that's cheap.
This gets really messy, I think, in a way that I like, because actually it's kind of proving the point in a way that everyone would come at you from their position and agent base, right? So whatever references, like whatever way they've learned how to define a machine or to define philosophy or whatever, they're all going to put that on you. And in a way that's constraining, but at the same time, like part of what we're trying to do is find a practical way of expanding that. Isn't it connected the way that, like, the practical work that you're doing in the lab and how it would change actually maybe a linear way of thinking, for example, that's an assumption that, there's a beginning and there's an end, and there's either something that has cognition or doesn't. That's so entrenched and such a scaffold that you almost have to call philosophical attention to it. But you also need, which is why, again, I'm so excited about your work, you need practical, actual examples of how to understand that, right? And that's kind of what I see in your work, but I don't know.
Yeah, no, you're right. The definitions, that's really important, because it's kind of a strategic judgment call all the time. And because for example, somebody said to me once, we were talking about learning in some weird unconventional systems, some cell thing, and she said, look, you're going to have so much pushback to this. Why don't you come up with a different word? don't use learning, come up with something else, and then it'll be fine, and nobody will be upset. You
Mm.
just define it however you want, and then that's good, right?
Yeah.
And okay, sometimes maybe that's the thing to do for a particular purpose, but overall, like I think that to me, I think back, here's Isaac Newton, and somebody says to him, you know what? We'll have gravity for the thing that holds the moon to the earth, and then we'll have schmavity for the thing that makes the apple fall, right? That'll be great, and then nobody
Hmm.
has to be
Hmm.
freaked out by, like, yeah, I mean, great, but you've missed out on the whole point. You've missed out on the unification, and so most of the time, I'll say, no, I don't want to use these words the way everybody else uses them, because a lot of it is wrong. And we as scientists and as philosophers, it's on us to clear this up, because people will say all the time, yeah, but when, don't use intelligence like that, because when you say intelligence, people think human intelligence, right? Well, they need to stop. And so, and
Yeah.
it's not going
Yeah.
to stop until the scientists put forth a better system, and then eventually it sort of trickles down. So it's a judgment call, when you sort of bow to the conventional usage and come up with other terms. But much of it, I think we got to be the tip of the spear in changing, because that'll change perception, and eventually the usage will change.
And that's kind of the dance too, that discussion and that maybe shock, right? Like,
Mm-hmm.
I think even there's a way in which, if you could open the space to understand, okay, we don't all use these words in the same way.
Mm-hmm.
So maybe I'm not using it in the same way as you. Let's like talk about that.
Yeah.
How, why is this shocking for you or not? And,
Yeah.
but of course, then you can get mired in the philosophy and not in the practical aspects too. So before we met today, I was thinking, like, what are the big issues, like, I don't know if you think about it too much, you probably do, but you're doing a lot of work and it's a lot of energy, and like, what is it? What's kind of what's driving you? What's the motivation behind it? To
Yeah.
try to get something practical.
Yeah, I mean, it's an interesting thing, because I sort of go back and forth. So on Mondays and Wednesdays and Fridays, I think uh, the real goal is to come up with practical interventions that improve people's lives. In other words, I'm not even a clinician. Okay, I don't do clinical work, but I get emails every day from people in the most unbelievable circumstances. I mean, birth defects, cancer, missing limbs. I mean, just the craziest things. The things I've never even heard of.
They
You know,
want you to help them with some
yeah,
kind of
yeah, yeah, and
regeneration.
they need help, and medicine is still largely stuck where computer science was in the 40s and 50s. It's all about the hardware, right? When I give a talk, I show this picture of, like, she's rewiring the thing. Yeah, this is now molecular medicine, and I think
Mhm.
until we fix that, and until we really learn to take advantage of the intelligence of the various layers of our body architecture, all of these things are not going to be resolved. And so every other day, I think that's got to be it. Nothing is as important as permanently moving medicine to fix some of this stuff, so that I can finally, like, I mean, just on a personal level, like, I'm driven by the fact that, yeah, I get these emails, and right
Mhm.
now all I can say to them is, we're working on it. Like, hang on.
Yeah.
Well, how satisfying is that, right? And so
Right.
and so on alternate days, I'm like, yeah, we got to drive everything to medicine. And then on sort of Tuesdays, Thursdays, and Saturdays, I think to myself, well, actually, none of that is going to be fundamentally changed until these really basic conceptual things are sorted out. So no one can really move in that direction. It's not enough for me and my lab to be working on some of these therapeutics and whatnot. Everybody has to be empowered by it, and that means getting some of the very basic stuff sorted out. And that means, these. And so people write to me on that too. I get emails saying, stop doing all this philosophical crap and just, like, work on cancer and then be done. And then there are the other people that say, I'm seeing your papers about, this kind of method and that kind of, enough of that. Like, those are details. Where's the, work on the
Mhm.
deep philosophical issues? Why are you spending so much time on this, this drug and that drug? So there's a wide ranging kind of opinions. I kind of go back and forth. I try to do some of both, I think. In my group, we have some of both going on. So yeah, I want to have a better understanding of embodied minds. I think that will drive medicine. I think it will drive a better set of ethics eventually. I think it will drive human flourishing and so on. That's long term.
Yeah, and I think by being able to stay in that place, that crossroads, it's not even just a matter of contradictions or different desires. It's also it can be really hard to try to hold that space and just keep doing all of it. I think this gets to this idea too of how we are usually we try to go into one discipline or one group or one something, because it gets very difficult, right, to try to be open to something that isn't binary and dichotomous or just like very clearly defined, even though most of us who've explored anything deeply know that nothing is clearly defined, and there's actually, like as you've expressed, it's very hard to find beginnings and ends to anything, depending where you're going to look at it. So is some of the work just being able to kind of keep yourself in a state of clarity so that you can keep sort of trying to express this, because sometimes it just takes time for people to be able to connect the dots?
Yeah, much of it is just me trying to figure it out for myself, and like on my YouTube channel is a bunch of conversations with of me and my coworkers and my various collaborators and so on, and that's just us in real time trying to figure out better ways to think about this stuff. This is very much uncharted territory. It's very much a kind of an unknown, lots of unknowns here. And so a lot of it is for myself and for us all to kind of try to figure out what are good ways to think about this. And this idea of the spectrum and the change and all that is really key. Oftentimes people just don't take developmental biology seriously at all. They'll say the human. I said, well, what exactly is a human, right? Because at one point that human was a little oocyte, and sort of so where did they say, well, when let's say when the brain development, that takes months. So what was actually happening on that? They sort of have this idea that these things just sort of pop into existence, and then there you go. But actually, no, you've got to do the hard work of figuring out if we're going to have a rigorous theory of whatever it is we're talking about. You have to have a story to tell about when it shows up and why. And if you think it's binary, you have a really hard story to tell about how that phase transition happens and so on. I was in this kind of funny story. I was in court one time as an expert witness on something, and some
Wow.
drug
That's intriguing.
drug effects on birth defects,
Okay.
fetuses. And the opposing counsel was trying to make it seem like he wanted to discredit whatever I was going to say as irrelevant to human medicine, right? So he says Professor Levin, you work on frogs, right? And I said, well, yeah, among other things, yeah. And he says, don't frogs come from an egg? And I said, well,
Oh no.
and it just kind of popped out. I said, well, you came from an egg. And the judge
Yeah.
starts banging the thing. Everybody's yelling because they thought I was trying. They thought I was being rude to them, and they're like, "Oh my god!" And the
Oh
judge says,
no.
And I said, "No,
That's
no,
just
no." I said,
true.
"Your Honor, you don't understand. Like you too, and me, all of
Yeah,
us
yeah.
came from an
All
egg.
of us.
Like think about it." And then it was just dead silence, and everybody was trying to visualize their seventh grade sex ed, and like, wow, we did come from an egg, but no one thinks about this. You just sort of
Oh,
think
that's
you're
a
this
movie
like
moment right there.
I mean, it was incredible. I was like, wow,
Yeah.
this, out of all of these, brilliant people, nobody remembers that, yeah, we all, Frog and us and everybody else, just about, we all come from one cell. And
Yeah.
they have this notion of, you're 18, you're an adult, like bang, something happened, the clock ticked over, and now, I mean, we know that's a nonsense story, right? It's a
Mhm.
continuum. It's always a continuum.
Yeah, but just to even have that realization is a pretty big thing
Mhm.
for a lot of people in their life, I think, and also a hard thing. I mean, I think it's hard to realize you're not as solid as you think, or that everything is sort of continuous and there's no clear boundaries. These are hard things for us in the way that we currently think of ourselves, right?
Yeah.
Because we kind of come to awareness of ourselves in this particular way. So we assume all these things. We don't think about all the many, many, many creatures that we are.
Yeah.
Do you think, I mean, I guess, do you see that in reactions to your work too, that people just have an almost visceral reaction of it just being a difficult thing to get a hold of due to their sense of self somehow.
Yeah, it's interesting, and I also I collaborate with a bunch of folks who study in the Buddhist tradition and so on, and they of course have a different take on all of this. But yeah, I see kind of I see two reactions really. Some people are really sort of liberated by it and feel really good about it, and because it makes things make sense. All these really hard pseudo problems that were bothering them before, now it's like, oh, I see. If you don't try to make it binary, and if you have an observer based kind of perspective, then these things go away. There aren't these inconsistencies that are really, we're not ever going to be resolved.
Do you think of like a practical example of that? I mean, I know what you mean, but
well, for example, just this business of and we can talk at length about this issue, but just this issue of the changing self, and the fact that if you think about it, you don't have access to your past, which at any given moment, what you have access to are the engrams that were left for you by your past self, and it's on you to interpret them and to construct memories and to figure out what you are and who you are. And you have to do this all the time. This isn't just what planaria do when you cut their head off. This is, all of us are doing this all the time. And so
right. And just in different ways according to who you're with and what situation you're in.
Yeah, and just realizing that's okay. There is no need to try and formulate some sharp thing that I am this. Yeah, but you were 5 years old once. What happened to that being? And these crazy questions that you can ask it, but you don't need any of that. You can just sort of realize that this is a progressive kind of process, and it doesn't mean that you don't exist, and it doesn't mean that your mind is an illusion. That's these things people say. Something, I don't mean any of that, but it does mean that it's a construction, kind of construction process. And then people start to think about stuff like, because of all the AI stuff, there's some people that are trying to develop proof of humanity certificates, right? So that it's actually a person. Wow. And so you think about that and you say, okay, what do I want? I'm designing a proof of humanity certificate. What do I want to make sure of? Do I want to make sure that you have standard Homo sapiens DNA? I don't know about you. I could care less about your DNA. Do I want a certificate that says I've got all my original organs? I don't care about anybody's organs. If somebody had a bunch of stuff replaced with new sort of cyborg stuff, I mean, great.
Or livers regenerating.
Yeah, exactly, right. What do I care? And again, this is all, you get all this from sci-fi. People who have never read sci-fi find all this crazy, but in science fiction, they did all this 150 years ago. This was all done. And so you think, no, I don't care about any of that. And so then you ask yourself, so what do I, what does it mean to be a human actually? And people ask this too when I talk about and of course I'm not the first by far person to talk about this idea of freedom of embodiment, that at some point you want to have tentacles and see infrared, knock yourself out. It's all going to be possible. You want to have a primary sense of the stock market and the solar weather instead of vision, like, sure, why not? So all of this is going to be possible. And she says, oh my god, then we're going to lose our humanity. And you just ask, was your humanity tied to your wacky set of organs that you ended up with that are susceptible to all sorts of weird diseases and parasites? Like, was that really it? Or your genes, which were the product of this sort of meandering search through genetic space? So that leads you to ask, like, what is really critical here? And where I ended up was, we have a couple papers on this idea of compassion and cognitive light cones, and this idea that, well, what you want from a human really to know that if we're going to be stuck on Mars for the next 20 years, what I really want is for us to have an impedance match in our cognitive light cones. I want us to be able to care about the same scope of things. If you're a Roomba,
cognitive light cones, that's great. Sorry, I just have to say that again.
Cognitive. Yeah, it's
what is illuminated, sort of.
It's specifically, so it has I give it a very specific definition. It's the scale of goals that you're able to pursue. So if you're a bacterium, spatial and temporal, right? Your scale of your goals are very tiny. And if you're a dog, they're bigger, but they're still, you're never going to care about what happens 3 weeks from now, 2 towns over. It's impossible. Whereas if you're a human, you might have planetary scale goals about things that go on long after you die and so on. So this cognitive, so we want a kind of impedance match about the kinds of things we care about. And you want at least, but hopefully more, but at least a human level of compassion to literally being able to care about a certain number of a certain size of welfare of other individuals, right? And maybe there are beings out there who do way better at that than us, but at least minimally
Maybe
that.
we'll learn how to be those beings.
That's exactly right. And we talk about in this paper, the team and I talk about this idea of enlarging, committing to enlarging your cognitive light cone and enlarging your sphere of concern. And this is something that, of course, in the Buddhist tradition, they think about a lot. So people.
Oh, I love this so much. Gosh, wow! I need to find that paper. I haven't read that one yet.
I'll point you to it. So some people sort of get this, and it's clarifying for them. It makes them feel better. They don't need to worry about getting an implant or change, or getting their DNA repaired or anything like that. They sort of feel better. Other people, so oddly, I mean, I find it surprising, but other people are profoundly destabilized by all this stuff. And it isn't just me. It's sort of like there's this, and with the same group, we're writing some stuff about this. There's a lot of so if you're a thoughtful person and you read some physics and some neuroscience and stuff, you find out that well, let's see, evolution theory tells us that there really is no morality. It's all dog eat dog and survival of the genes. And then neuroscience, you read like Sapolsky's book or something, and they tell you, well, there's no free will. So you're just sort of humming along on whatever was ordained whenever. And then right, so you get all this stuff, and then here comes Levin tells you that you're a bunch of cells in a trench coat, and you're this thing that's sort of constantly morphing and whatnot. Again, I'm not a clinician or anything remotely close, but I get these emails that say, well, I know you're not a therapist, but and then they go on with this stuff and I'm like, wow, this is terrible. I really wish.
It's a lot to handle. My goodness.
Yeah.
And from all sides,
Yeah. It's amazing because people feel, I think, even though I don't talk about that stuff publicly, but people feel like this impacts on their life, that the answers to these questions are not just like crazy, nerdy philosophers think about this. So this actually matters, right? People feel that, and they get, and some people get really destabilized by it. And I try to, I try to walk some folks, sort of off of that ledge, and it's funny, even in the movie. Have you seen this movie Ex Machina? Have you seen that?
Yeah, I have.
So you know the scene where he's at the mirror and he's cutting his hand because he's worried that he's a robot too, right? And so
yeah.
And this is
why are you so worried?
That's exactly right, because many people think if I look inside and I suddenly find a bunch of cogs and gears and whatever, then I'm not as amazing as I thought I was, and I don't have this and I can't do that. Or how about the alternative interpretation, which is you didn't learn a thing about yourself. What you learned is something cool about cogs and gears. You just found out that, well, geez, I guess cogs and gears can give rise to my amazing self. Awesome. I'm now going to do whatever it was I was going to do 10 minutes ago and good. Yeah. Right. So people immediately, some people, I guess, immediately jump to the first interpretation, that this somehow takes something away from them. And I think this is one of those things that Descartes actually got right. I mean, he catches a lot of flack from everybody nowadays, but I think he got this right, which is that you have a primary perception of your primary experience is of being an agent that can go do things and that has certain properties. Nothing can touch that. If you find out that you're made of this or that, delightful. Now you've learned something about whatever material you're made from. Go do whatever awesome thing you were going to do before you found this out. It's fine. It doesn't mean anything.
Yeah.
So I try to kind of, go through this with it. So some people, so anyway, that's a long question to your answer, but some people find it really liberating and some people find it disruptive.
No, this is great. It makes me think of so many things, like even in Buddhism, sometimes, they say that that too can be a very jolting experience if you have an experience of kind of non-self or of, a lot of this is just regularities. And to get to this idea of navigation or waymaking or whatever, if we try to think of it as like trajectories, that we've all come on kind of different trajectories with different regularities. And sometimes we cross paths with people who have very different ones, right? As you're talking, I'm thinking of the television set in the caterpillar and how from very early on, this was a comfort zone. You were able to kind of deal with all those different, what's for some people are very different things, like a machine, like in this TV kind of way, and a biological body, right? I mean, but when you haven't thought about all that stuff and then you're sort of presented with it, I think it can just be very jolting, but in a way that's, if you can walk through it or sit with it for a minute, it can become enlightening too, in the way that you described with the ex machina, right? If you can kind of, some of it is this practice of learning how to shift scales or shift perspective to look at life from the point of view of the caterpillar or the television or whatever, right? Like that's a kind of practice in itself, isn't it? That maybe we learn. Yeah,
it is. And not to beat this dead horse, but the sci-fi thing is really useful for that, because it helps you take there was a story called They're Made of Meat. This old science fiction story, right? Remember this? And these aliens find out that humans are actually made of meat. They're disgusted. They're like, this cannot be, right? Like, what the hell? Gross. And here we are, everybody's saying, oh, it's a silicon thing that can't be real. All of this stuff is a matter of perspective until we really develop. And I think this is what the field of diverse intelligence is about, is to develop principled approaches to recognizing agency, to relating to other beings. And by the way, all of this goes back to our discussion about terminology. All of this is about I think practical optimal relationships to systems, right? So when I talk about the spectrum and I say, well, yes, a human, but really what human? Like a modern human, a child, a baby, like a fetus, like what are we talking about? And then people say, well, you can do that with anything. That's the paradox of the heap, right? They say that's not a good way of reasoning, because you could do that with anything, and you can say, well, I'm going to pile sand, a pebble at a time, and eventually you've got this heap.
When do you have the pile?
When do you have the pile, right? And so my answer to that is, oh no, it's extremely practical. If you call me on the phone and you say, hey, I need you to help me move a heap. Here's what I need to know. Am I bringing a shovel, a spoon, a bulldozer? Like, what am I bringing? And that's all, right? We don't need to have a philosophical discussion. We need to know what bag of tools is going to be the way to relate to the system. And I think that is exactly what we need to do in science, is to erase some of these barriers. When I was a postdoc, I was having this idea of using expressing ion channels from neurons in other types of cells to manipulate the bioelectrics and embryos. I wrote some letters to Neuroscience asking for ion channel plasmids, and this one guy called my boss, my postdoc mentor, and he said your postdoc has gone off his rocker. You need to do something about this. He's clearly crazy. But the fact, which was great. But the fact is that actually none of the tools of neuroscience distinguish neurons from non-neurons. You can use it. All of the stuff works. The optogenetics works. The drugs with the target the different serotonergic machinery and ion channels. All the conceptual stuff work. The multi-electrode arrays, the conceptual stuff, active inference, and all of these perceptual control. All of these things work outside the nervous system. Great, they work very well. If the tools can't tell the difference, who are we to put up these barriers and say that's the neuroscience department and that's the developmental biology department, and don't try to, they're different. They're just completely different. I think it's totally artificial.
Oh, it makes me, there's so much, it makes me a little too excited to try to say all this at once. But I think, again, it comes back to that agent base and scale. Where are you measuring it from, right? If you're an ant, a sand pile is going to be different than if you're a human. Exactly. And also kind of like learning, if we take this really seriously in a practical way, what we're talking about, you realize, and that's the scary thing, that you're not what you thought you were, this like only human, right? You're experiencing that scale, but we develop all kind of tools and measurements to measure at many different scales, whether it's like looking at the scale or looking at the planets or whatever. And science fiction too, we tell stories as ways of also measuring from different perspectives and scales. Like, this is obviously kind of what we're trying to do. And maybe there's a way to say, okay, well, now I'm at this like human self scale of my trajectory and narrative, but I can also look at like the cellular scale or the planetary scale, or maybe put myself in another person's shoes or something like that. Yeah, but so there's all that I would love to talk about, but also I just to try to get it back to like the science, and you mentioned the neurons, right? And I studied neuroscience, and this is really interesting, even to kind of tie it to Descartes, because you brought up Descartes, of mental, physical, right? And how we've come to think of the brain, the cells in the brain are special because they're mental.
Yeah.
Like, because from our agent base, that's how we see it, right? And it seems different than the cells elsewhere in the body, but I hear you saying actually they're all doing something similar, right? It's just where are we measuring it from and what are we measuring?
Yeah. Well, two interesting things there. One is this issue of measurement. My feeling is, and this is just a conjecture, but my feeling is that the reason that physicists see machines and not mind is because they're using low agency tools. So when you have voltmeters and rulers and things like this, you're using low agency tools, and there needs to be some resonance between what you're using and what you're going to find. Right. There's this old saying, show me the net you're using and I'm going to show you what fish you can catch. Like, yeah, the tools, if you use low agency tools, you find low agency stuff. What's a high agency detector? Well, minds are. Like we have a lot of blind spots, but we can recognize at least certain kinds of agency. And so when you use a high agency tool to look for things, well, guess what you find, right? So I think measurement, you have to think about what your measurement tool is going to let you find. And then the thing about the cells is and the neurons. I've been in discussions where we'll have a conference about this kind of stuff, and somebody will give a talk and they start out and they say, well, neurons, and I sort of say, well, so hold on, what's a neuron? And they say, come on, neurons. I said, but no, really, like, what's a neuron? And of course you don't do this in neuroanatomy 101, because there you need to just agree and move on with your life. But in meetings like this, they say, well, what's a neuron? And they say, okay, fine, and they'll write down 4 or 5 criteria for what a neuron is. And I'll say, yeah, but every cell in the body does that. And they say, well, that can't be. And no, actually, yeah. In fact, the Koshland did some nice work on neuroscience and bacteria. And they say, oh, well, then it's got to be the higher level thing. It's they work together. They make networks to solve problems and to represent information. I'm like, yeah, pretty every cell in your body is doing that, especially during development and regeneration. So
and it can all look a lot like cognition if you take it from the position of whatever agent is using it or is involved in it.
That's exactly right. And so I've been pushing this idea, which is not super popular by any means, but this idea that morphogenesis is literally behavior in anatomical space, exactly like conventional behavior is in 3-dimensional space, and that it's the outcome of a collective intelligence, in one case of neurons, in the other case of whatever other body cells you might have. That it's literally the same process. It shares molecular underpinnings. We have a cool paper on that coming out soon, but also algorithmically it does a lot of the exact same stuff.
It gets back to those patterns and regularities and how they scale and how they're never discontinuous. So if you can find the right tools to measure them, you can probably see their continuity from scale to scale. But this gets at this idea of kind of trying to understand cognition in a different way, which is what I'm really interested in, because I feel like that's one way we can start to understand, get past the linear and look at like maybe a multidimensional, many-scaled kind of perspective of the world. If we could understand that cognition is something that's happening at all levels and in all species, but that doesn't mean it's the same cognition or something. And I know you use the term navigation, which I used to use, and someone kind of in neuroscience, as you know, that always means that there's a goal. As opposed to waymaking or something. So I changed it to waymaking. But I wonder, like, when did you start thinking about cognition as navigation, and like how does it relate to all the stuff we've been talking about?
I like your point about waymaking as kind of a broader thing, because I agree it doesn't always it doesn't always have to have a goal, but it, well, when I first the two things sort of coalesced for me at one point. It was about they sort of came together in right around 2018. One was that I love this idea of the latent morphospace. This idea that shapes that we see are particular regions in morphospace, and this was, back in even Darcy Thompson in his classic on growth and forms, the growth and form. The my favorite part. I mean, the whole thing is fascinating, but my favorite part of it is there's 4 or 5 pages where he makes a grid, just like a two-dimensional grid, and he draws some sort of an animal on it, and then he deforms the grid with these mathematical deformations, and then what you get is another kind of animal. And so this was, the 20s, I think, or the up until the 40s, something like that. He was doing this stuff, and you look at this and you say, what the hell is that grid? Like, what is he actually deforming? But what physically, biologically, but what you realize is that any anatomical change is a move in this morphospace, and therefore the normal journey from egg to whatever is a set of deformations in this morphospace. In fact, more recently, I've started to believe that actually that development is really just an instance of regeneration. So anyway, and so I was thinking about, so I was already thinking about this idea that these are really all just sort of these movements in morphospace. And then in 2018, I was at a meeting at a diverse intelligence conference in Scotland, and Pranab Das sort of laid out this challenge, and he said, I want people to think about a framework in which you can put diverse intelligences. You can directly compare and contrast very diverse intelligences. And so people were thinking octopus and and slime mold and things like that. And I heard that and I said, well, so conventional beings, but also swarms and aliens and AIs and weird synthetic shit that we make in the lab. And like really, let's really sort of be inclusive and ask what is the underlying invariant in all of this? What is an agent? And then I came up with so my take on, and of course other people have said things about this before, but I kind of went with this cognitive light cone idea, and they said whatever you're made of, however you got here, meaning evolution, engineering, however you got here, the only way you're going to be an agent is if you have the ability to pursue some kind of goal and that will your set of goals will have some sort of envelope of the biggest goal you could possibly conceive and follow. And that doesn't mean that every action has to have a goal. You could be exploring, you could be just hanging out, that's fine. But as an agent, you have the ability at some point to pursue some states that you prefer over other states. You have to have preferences, valence, and so on. And so that then realizing, well, first I drew it and I said, okay, so this is, spatio-temporally in 3-dimensional space, you have these goal states. And I thought, wait a minute, but this could also be a transcriptional space. It could be a physiological state space. And of course, it could be anatomical morphospace. You could have these goals of, I'm going to be a limb and I need to get from here where I'm a limb bud and over here. And of course, you have all these. And so then I was like, well, what all these things have in common is waymaking. It's what you said. It's the ability to adaptively navigate these spaces to get to regions that are more pleasant for you, basically.
Gosh, I love it. I have to just dig in here a little bit. I'm not really clear about how, but I'm just going to talk. But is it so to know you're an agent, you would have to have a goal, but maybe you could be an agent to someone else just making way, right? Just you're making any kind of a way. So I'm trying to get at that distinction. We were talking about measurement before, and that word bothers me sometimes because of all the references and the trajectory and the history that comes with measurement and how it sounds very, it can sound a certain way to certain people.
Yeah.
Maybe assessment is better or something. But there's I wonder how you see this relationship between the observer and what it is to be an agent. And, if that relates to navigation. I mean, I also use navigation in my master's thesis because I think it expresses what I want to say about what cognition is. But yeah, we also just wander around.
Yeah.
We, any kind of life, even a tree or something, is making its way. It doesn't necessarily mean moving from A to B or something like this. But
well, I mean, it is in physiological space, it is moving all the time, right? In three-dimensional space, it's not moving, but in physiological space and also in transcriptional space, it is moving.
Right. Depends how you exactly. It depends what you're like the spatio-temporal scale from which you're looking at is going to
and which space, right? Like we're in love with three-dimensional space because all our sense organs point outwards. So because of our eyes and everything, we love 3D space. But you know, I think if we humans evolved with a primary sense of our own internal physiology, so like almost like a tongue, but it faces inward, so you know exactly what your blood chemistry is at all points. And I think we would feel like we're living in a high dimensional space, that our livers and our liver and our kidneys are intelligent agents that are solving problems in the space, because we would be able to feel them doing this. We just, you know, we see squirrels and stuff running around in 3D space, and we're sort of good at recognizing that. But if we had the sense organs, I think we wouldn't have that.
And maybe we're trying to get there in a way with our tools and stuff. And also just how much can we handle, right? How much can like the system handle? It maybe can't handle being so aware of that. Maybe later we can.
But, maybe. I don't know. I mean, you know, with all the work on augmented and I apologize, I have about 4 minutes, but before my next thing,
gosh.
We'll schedule, you know, we can schedule another chat.
Okay.
You know, sensory augmentation and you know, these weird prosthetics and everything. I'm not sure we know how much we can handle. I think we could probably handle a lot. And I fully agree with you that I don't think you need to know that you're an agent in order to be an agent. I mean, that's a particularly advanced sort of metacognitive thing. But even back, so here's a super simple version of this, right? Bacteria. So you got a bacterium, and it can sense the sugar concentration, and that helps it go up the sugar concentration gradient, right? It loves that. But now, what if the sugar is poisoned somehow, right? That thing is going to fail, because so what some bacteria have is they have a metacognitive loop where instead of tracking the sugar concentration, they're tracking the output of their own metabolism. So the question is, so there you say, I don't know the details of what's going on, but how am I doing? Right. And if the answer is, well, yeah, the sugar sensor is firing gangbusters, but you're not doing very well, then the answer might be, well, then I need to get the hell out of here. Something's not right. So this ability to
even that is scaled. There's always assessment going on.
It's assessment, right? This ability to, you know, measurement doesn't mean somebody, you know, with a ruler who sort of has a deep understanding of what the hell they're measuring. It's constant, and the ability of beings to measure internal states in addition to external states, that leads, I think, directly to this kind of metacognitive feedback loop, where eventually you can tell very complex stories about, you know, the agents around you, and oh, by the way, I'm an agent too, and so on. So we can talk
where
about
you
that.
actually have to expand into different spaces.
And
just I really like, we'll have to do it next time, but I want to think about this idea of regeneration too, and like, can you regenerate if you've never had that trajectory? Can you even we'll have to talk about it next time, but if you looked at the planarian or something, and could it regenerate without sharing like the regularities of whatever is being regenerated? I mean, there's also some weird constraint there, isn't there? Kind of.
I've got a couple of cool stories about that to tell you. So we can talk about xenobot regeneration, which is relevant because they have never existed before, right?
Yeah, that's so cool. Yeah, we have to talk about that.
Yeah, and
even that, they're kind of we'll have to talk about it.
Thank you so much. It's great to meet you. Let's talk again, and I really want to hear more about your work and what you're up to.
Thanks so much. I appreciate your time.
Yeah. Okay. I'll see you soon.
Good luck with everything. See ya.
Thanks. Yep. See ya.
Bye.